Regardless of your location worldwide, be it volcanic rock in East Africa, limestone cliffs in Europe, or granite mountains in South America, you are enveloped in a narrative. This narrative encompasses a 4.5 billion-year-old tale inscribed in rock and mineral. I am Faith, and this video marks the initiation of our exploration into the captivating disciplines of mineralogy and geology. This is Topic 1 of MGEB 210. By conclusion, you will attain a clear understanding of these sciences, their origins, and their profound significance to you, your community, and our planet. Let us commence with two fundamental yet profound inquiries. First, what is the composition of the ground beneath your feet? Second, how did this substance come into being? These two inquiries lie at the core of our course. Understanding them necessitates knowledge of minerals, the fundamental components of all rocks, and the geological processes that have sculpted Earth for billions of years. Today, we delve into the scientific answers to these pivotal questions. Mineralogy represents a branch of Earth science dedicated to studying minerals. However, what precisely defines a mineral? A mineral is a naturally occurring, inorganic, solid substance characterized by a specific chemical composition and a crystalline structure. Let us analyze this definition word by word. Naturally occurring indicates it forms in nature, not created by human intervention. Inorganic signifies it does not originate from living entities. Solid denotes it possesses a stable shape under standard conditions. Definite chemical composition implies every sample of the same mineral possesses an identical chemical formula. Lastly, crystalline structure indicates that its atoms are arranged in a regular, repetitive formation. Minerals such as quartz, feldspar, calcite, and pyrite fulfill all 5 criteria, whereas coal and pearls do not qualify as true minerals due to their organic nature. Mineralogists meticulously investigate these properties, which include a mineral's color, hardness, luster, cleavage, and specific gravity. Each property aids in determining a mineral's identity and its origin. This expertise offers substantial practical benefits. It guides us toward valuable ore deposits, informs processing methods, and addresses environmental impacts stemming from mining activities. Geology encompasses the study of Earth, its materials, structure, processes, and historical narrative. The term derives from the Greek ge, meaning earth, and logos, referring to study. Geologists pose essential questions. How were these sedimentary layers formed? What is the age of this terrain? What geological forces elevated these mountains? Why do earthquakes and volcanoes manifest in particular regions? The field of geology can be broadly categorized into 2 main areas. Physical geology examines the materials constituting Earth and the processes affecting it, including weathering, erosion, volcanic activities, and tectonic movements. Conversely, historical geology reconstructs Earth's past, utilizing fossils, rock sequences, and radiometric dating to visualize Earth's appearance millions or even billions of years ago. Together, these 2 branches provide a comprehensive perspective of our dynamic planet. Geology comprises several specialized branches. Petrology focuses on rocks, while geochemistry investigates Earth's chemical composition. Hydrogeology addresses groundwater issues, and volcanology scrutinizes volcanic phenomena. Economic geology finds commercially valuable mineral resources, while environmental geology evaluates the impact of geological processes on human existence and ecosystems. In this course, we will engage with all these areas. Now, let us journey back to trace the development of these sciences. Humanity has engaged with rocks and minerals since the Stone Age, crafting tools from flint, weapons from copper and iron, and pottery from clay. However, scientific inquiry began notably later. In ancient Greece, philosopher Theophrastus penned On Stones around 300 BCE, offering one of the earliest systematic descriptions of minerals, rightfully earning the title of the father of mineralogy. In the late 1700s, Scottish geologist James Hutton revolutionized our comprehension of Earth's history with his principle of uniformitarianism, asserting that the present is the key to the past. This principle implies that geological processes observed today such as erosion, deposition, and volcanic activity, have persistently influenced Earth throughout its history. Hutton is widely regarded as the father of modern geology, with his ideas further disseminated by Charles Lyell, whose seminal 1830 text, Principles of Geology, became a pivotal reference in 19th century geology. German scholar Georg Agricola authored De Re Metallica in the 1500s, laying foundational principles for mining and applied mineralogy. In 1912, Alfred Wegener introduced the audacious theory of continental drift, suggesting that today's continents were once amalgamated into a supercontinent known as Pangaea. Though initially met with skepticism, his propositions ultimately contributed to the formation of the contemporary theory of plate tectonics. Mineralogy and geology are intricately linked through the rock cycle, a crucial concept in earth science. All rocks undergo a continuous cycle of transformation. Molten magma cools to generate igneous rocks. Over time, surface processes such as wind, water, and temperature fluctuations lead to weathering, breaking down these rocks. The resultant fragments are transported and layered to create sedimentary rocks. When subjected to significant heat and pressure deep within Earth, any rock converts into metamorphic rock, restarting the cycle. At each phase of this cycle, minerals are forged, obliterated, and recreated. Grasping mineralogy enhances our comprehension of what transpires during each stage of this cycle. Why is this knowledge significant? The answer is omnipresent. The device you hold contains over 60 distinct minerals, including lithium, cobalt, and rare earth elements. The structure you inhabit consists of cement from limestone, steel from iron ore, and glass from silica sand. The food you consume derived from soil shaped by eons of rock weathering. Clean drinking water resides within geological formations called aquifers. Responsibly identifying and managing mineral resources poses one of modernity's greatest challenges, intersecting with climate change, sustainable development, and environmental stewardship. By studying mineralogy and geology, you are positioned to engage in these essential discussions. In summary, we have explored today the essence of mineralogy, the scientific examination of minerals, defined as naturally occurring, inorganic, crystalline solids with explicit chemical compositions. Geology, conversely, investigates the Earth in terms of its materials, processes, structure, and historical nuances. These sciences originated from ancient philosophical inquiries, culminating in the formal studies of notable individuals such as Theophrastus, Georg Agricola, James Hutton, Charles Lyell, and Alfred Wegener. The rock cycle illustrates the ongoing transformations of Earth's materials, linking mineralogy and geology, showing their immense relevance in areas ranging from mining and construction to agriculture, environmental preservation, and sustainable development. In our next session, we shall delve deeper into the branches of mineralogy and geology. I look forward to your presence in the next lesson.